In this video, we are going to review how to solve linear equations on a variable and how to solve a system of two linear equations and two unknowns. Let's begin with our linear equations. So let's say we are trying to solve 4x minus 3 is equal to 0. That is, we want to find for which value of x this equation is true. Our goal is to find the value of x, so what we're going to do is to isolate x. So we want to have x on one side and everything on the other side. So we are going to begin by summing 3 on both sides. If we sum the same numbers on both sides of the equality, we maintain the equality. So this is true if and only if. Now we have the negative 3 plus 3 cancelling. So we have that 4x has to be equal to 3. We do not want the value of x, we want the value of x only. So we are going to divide both sides of the equation by 4. If we divide the two sides of the equation by the same non-zero number, we keep the equation. So now we can cancel the 4 that is multiplying the x, and we have that x has to be 3 over 4. So we found that for 4x minus 3 to be equal to 0, we need the value of x to be 3 over 4. And that is easy to believe, even to guess, and very easy to check. So this was our first example. Could be that our equation looks more complicated, but it's not really going to be more complicated because we can't really make it very complicated with a linear equation on x. Let's say it looks more complicated because we have 4x minus 10 is equal to 2 minus 7x. Well, we want to have all the x on one side and all the other numbers on the other side. So we are going to begin by adding 7x on both sides. So on the right hand side, the negative 7x cancels with the 7x we are summing. So we have that 4x minus 10 plus 7x is equal to 2. That's it. If we collect together the x we have that 11x minus 10 is equal to 2. Now we add 10 on both sides, so we can see that 11x is equal to 2 plus 10, so 12. But we do not want to know how much is 11x. We want to know how much is x. So divide by 11 to be able to cancel the factor 11 multiplying x. And we say that x is equal to 12 over 11. So this wasn't really, it wasn't any harder than the example 1. Just we had to do a few more steps, but that doesn't make it deeper or harder. We can't really make it harder. I can try to scare you out. Let's say I can make ugly numbers and can write symbols, and you may think that this is getting harder, but when you see that it is not, in fact. So let's say that we have square root of 2 multiplying x plus 1001 is the same as 6 pi minus x over 27. Does it look harder than the examples 1 or 2? Well, it's not really harder than the examples 1 and 2. We are not doing anything different. The only thing is I would like to get rid of this denominator 27. So I'm going to begin by multiplying by 27 both sides of the equality. So we are saying over here, we are going to have the 27 multiplying each of the terms. So we're going to have 27 times square root of 2 times x plus 27 times 1001, whatever that is. It has to be the same. And now when I multiply the 27 on the right hand side, we're going to have 27 times 6 times pi minus x. We got rid of the denominator. That was the whole point of this multiplication. Now we have the first term on the left hand side and the last term on the right hand side to be the two terms with x. So we're going to collect them on one of the sides. Let's say we add x on both sides. So we are going to have that 27 times square root of 2 times x plus x plus 27 times 1001 has to be the same as 27 times 6 times pi. Okay, so if it was 27 times 1000, we have 27 followed by 3 zeros for the 1000, but actually we have 1001, so we need one copy more of 27 to add to our number, so we have 27,027, so 27,027. That's the number we have over here. And that's what we are going to subtract on both sides of the equality. So we have over here 27 times the square root of 2 times x plus x is equal to, okay, I need to do 27 times 6, 27 times 6, 2, I have 4 extra. Yeah, you can do this with your calculator if you want. I don't have mine handy. 162. So 162 pi minus 27,027. I'm going to take x as common factor because we have x in the two terms over here. So we're going to have that x times 27 times the square root of 2 plus 1 is equal to 162 pi minus 27,027. Since we want to find the value of x, we are going to divide by the factor multiplying x, so 27 times the square root of 2 plus 1 on both sides. So we have the value of x is 162 times pi minus 27,027 over 27 square root of 2 plus 1. Ugly? Maybe. It's all a matter of taste. In any case, this didn't involve anything that we have not done before. Just it looks more complicated, but it's not really more complicated. And that was it for our review of solving linear equations. Now we are going to review how to solve a system of linear equations. So let's say we have the following equations in x and y. 2x plus y is equal to 7 and x minus 2y is equal to 1. This is a system, which means that we want to find a value of x and a value of y, such that both equations are true at the same time. Let's see what is the geometrical interpretation of what we are doing over here. I'm going to write these equations as functions of x. So I'm going to write y in function of x. So I'm going to say that for the first one, y is equal to negative 2x plus 7. And for the second one, we will have that y is equal to x minus y, all of that divided by 2. You may want to pause the video and check that that's actually what we have over here. So I rewrote the system in this way because I want you to be aware of the fact that what we have here is a system of two equations and two unknowns, but it's also two lines that we have the equations over here. So let's graph how those lines look like. We draw the axis over here. Maybe I need to move it a little bit here to be able to fit everything I want to fit. Okay, the picture doesn't have to be perfect, but for the first one of the equations, the y-intercept is 7. So let's see here if I count 1, 2, 3, 4, 5, 6, 7 is gonna be here on the very top, but that's okay. That's a y-intercept of the line, and then the slope over here is negative 2, so it means each time I move one step to the right, I have to go 2 steps back. So the other point I have over here, this was at 7, this was at 5. and then x is 1. So the point 1, 5 is the other point of the line. So now we know 2 points of the line, so we can sketch the line over here. And of course I'm going to label which line is this, because we always need to have labels in our sketches. This is y equals negative 2x plus 7. That was the first one. The second one, we have, maybe let me write it as y equals x over 2 minus a half. So we have a y-intercept of negative a half. That's going to be the point over here. And then the slope is hidden over here is 1/2. So that means that each time I move 2 steps to the right, I have to move 1 step up. So that would be here, I move 2 steps to the right to get to x equals 2, and then I have to go 1 step up to get to a half. So I have 2 points. I can now sketch my second line. It will be something like this, and I will write the equation over here. Y is x over 2 minus a half. So what are we trying to find? We are trying to find a point xy that verifies both lines at the same time. So we're trying to find this point of intersection over here. Our picture is not perfect, but it suggests that we are going to get a value of x that is a bit more than 2 and a value of y that is a bit more than half, maybe around 1. So let's keep that in mind and solve the system and see if what we get makes sense. There are different ways of solving a system of linear equations, but since we already wrote the equations as y equals everything else, we can now say that since y is equal to negative 2x plus 7 and y is equal to x minus 1 divided by 2, then negative 2x plus 7 has to be the same as x minus 1 divided by 2. At this point, I'm going to get rid of the denominator 2 by multiplying both sides of the equality by 2. So we are going to get that 2 multiplied by negative 2x is negative 4x plus 2 multiplied by 7, that's 14. This has to be the same as x minus 1. I want to have all the x on one side, so I'm going to add 4x on both sides. So we get that 14 is equal to x plus 4x, so 5x minus 1. And our last step is going to be to add 1 on both sides. Pardon, sorry, that's not the last one. Now we are saying that 14 plus 1, so 15 is equal to 5x. But we still need to find what is x. And x has to be 15 divided by 5, so x has to be 3. I divide by 5 on both sides over here. Now that we found the value of x, it's easy to find the value of y. We know, for instance, that y is equal to x, so 3 minus 1 divided by 2. So we are saying that y is equal to 2 over 2 is equal to 1. So our solution is the point 3, 1, which kind of matches our not very perfect picture over here. I'm writing here 2 more systems for you to solve. And again, I want you, before you solve it, to sketch the lines involved here, so you see what is that you are trying to solve in each of these cases. 3x plus 3y equals 12. So please try those 2 more examples.